As a part of protection system engineering, we need to coordinate the relays which are being used in a power system network. Today's topic is about the overcurrent relay coordination. First of all, let's understand the basic. What are the ways we can coordinate the upstream with downstream relays so that the proper relay setting protection device coordination is there in the power system network. So there are three ways we can coordinate the protection devices. One is time. So based on the time discrimination, we can coordinate with downstream and upstream protective devices. Second option is by current discrimination, and third option is the time and current both. So in this video, let's discuss the first part, which one is based on the time. So let's draw a simple power system network configuration. Suppose this is a radial system. One generator is here, one circuit breaker, one bus. Suppose this is 11 kV generator. So this is, let's say, circuit breaker CB1. Then there is the outgoing feeder. This is 11 kV bus. This is, suppose there is a transformer. Here is CB2 and CB3. This is 415 volt. Like this. This is outgoing breaker. So here, as you can see, this is the upstream breaker, 11 kV breaker. This is also 11 kV outgoing breaker, and this is transformer incoming. Suppose this transformer is 11Y 0.415 kV voltage level. So this circuit breaker is 415 volt, that is LV circuit breaker, and this is LV outgoing circuit breaker. So whenever we are talking about the overcurrent relay coordination with these protective devices like CB1, CB2, CB3, and this outgoing breaker, suppose CB4. So whenever we are talking about this, that means we are going to coordinate from the downstream towards upstream. This is the basic principle of the protection coordination in a power system network. You need to set the relays or the circuit breaker. If the circuit breaker has the inbuilt release feature, I have already made another video for this LV circuit breaker release feature. That means ETU or electronic trip unit will be the built-in feature of this LV circuit breaker, this low voltage circuit breaker. ETU trip release. So in that case separate relay is not required. But for this medium voltage or high voltage network, we need to consider relays, and for that this is the CT. With this we need to consider relay here. We need to consider relay. Suppose this is relay 1, here is another relay. So suppose this is relay 2, this is R2. That means we need to coordinate with the downstream LV circuit breaker with this relay R2, and along with that we need to coordinate this R1 relay as well. Now coming to the topic specifically, what is the time discrimination? Time discrimination is that means that this relay coordination will be done by the time only, irrespective of the fault current. Suppose one fault occurs here in this 415 volt bus. Suppose here fault occurs, if fault occurs here, in that case this CB3, this circuit breaker 3 will trip first. Suppose with a time discrimination of 200 millisecond, then this CB2 will trip, suppose another 200 millisecond, that means at 400 millisecond. Suppose this is 200 millisecond, this is 400 millisecond, and this CB1 600 millisecond. That means with the time discrimination we are defining what will be the sequence of operation of these protective devices. So if there is any fault at LV side, that means 415 volt level, then the immediate circuit breaker will trip first, then another one, and then upstream another one. With the help of only this time discrimination, independent of the fault current, because this doesn't depend on the current, only the time. So that's why this is called the overcurrent relay coordination by time. Let's draw one TCC curve here. Okay, let's draw TCC curve. What is TCC curve? That is time current. So this side time t, y axis, and this side current. So this is time current curve. This is the only curve where the time is indicated in the y direction, in the y axis. In any other curves you will see the time is in the x axis, but here in the time current characteristic curve, TCC curve, the time is in y axis and current is in I axis. Whenever we are discriminating the protective relay devices based on this time, let's see carefully. So suppose this CB3, this CB3, that characteristic curve is like this. That means That means at time this time gap suppose t1 equal to 200 millisecond, this breaker CB3 will trip. Now if we draw this CB2 characteristic, then it will follow this path like this. So in this case, time t, this is time t2 equals to another 200 millisecond for the breaker operation and the safety margin. Okay, so this is 400 millisecond, and let's draw for the breaker CB1, the CB1 characteristic. If we draw like this, so here the discrimination will be this much. This is T3 equals to 600 millisecond. So at time t1 equals to 200 millisecond, this CB3 will trip in case of fault at 415 volt bus. Then CB2 is the backup protective device which will operate at 400 millisecond, and next backup protection is CB1 that will trip at 600 millisecond. Okay, that's fine. Now if you set what is the, now coming to the disadvantage of this time grading of overcurrent protective devices. The main disadvantage is that as you can notice that the CB1 tripping time is 600 millisecond. 600 millisecond, that means whenever you are going from the downstream towards upstream, the breaker operating time is increasing with the coordination. So this is 600 millisecond. If another breaker is there in between this, then another 200 millisecond, that means 800 millisecond, which is much more, which is longer for this particular circuit breaker, because this is nearer to this generator. So the main disadvantage is that whenever there is a fault at this 11 kV bus or nearer to this generator, that time CB1 will trip only at 600 millisecond, which is not acceptable, which is not expected, that this circuit breaker will wait until 600 millisecond to clear the fault, because this will damage the equipment or the power system network. So it is expected that with instantaneous time delay, this generator should be tripped, this generator circuit breaker should be tripped to protect this generator and other equipments. Whenever there is a fault at 11 kV side or at generator terminal, this circuit breaker should trip instantaneously, not at 600 millisecond. So this coordination well and good for this whenever the fault is far away from the source, whenever this fault is far away from the source, but not good for the fault location if this is closer to the source, whether it is grid or generator. So we cannot accept this time grading coordination over current coordination. So that's why it is generally not used in power system network nowadays. So this is the main disadvantage. So in this video we have discussed the overcurrent relay coordination by this time grading. In next video I will cover by this current discrimination.